Hello, this is Shakouri. I am in Silicon Valley, USA. I am Director of Community Broadband in Joint Venture Silicon Valley and co-chair of Agriculture and Rural Supercluster in Global City Team. Today, I will share with you some of our latest work related to rural prosperity and quality of life goals. The outline of my talk would be first introduce to you what is this four-letter acronym Global City Team Challenge is all about, share some of our latest work in agriculture and rural area, find some of our results based on our workshop and a blueprint that was published by NIST earlier this year. And then to bring it home, we have some couple of examples from the state of California and the state of Indiana, show some of the interesting innovation happening in this space, share with you some of the discussion about mapping, and finally, some of the needs for connectivity. Global City Team Challenge, GCTC, is a partnership between federal government and also state and smart cities plus technology companies with the main focus of what the future smart and secure cities and community should be about. It was more than 5 years work and has been looking at multiple different areas. This picture shows you a connected community, and I think it's great because when you look at it, you understand the complexity of the problem. You're dealing with mobility, access, you have cost applications like health, resiliency, smart buildings, you have civic engagement, privacy, government, and putting it all together is, of course, the challenge that is faced by community. So who is involved in the partners? As you can see in here, many organizations, for example, from NIST, NSF, you can see the nonprofit organization like Joint Venture, the organization that are doing innovation like US Ignite, plus many companies and technologies, and also many countries involved in this program. The message gets to outside. The main thing that the organization develop is what we call blueprint or playbook. The main thing is to help bring some case studies, examples, or summaries in a fashion that others can learn from and leverage. As you see, there is a website that you can go and download some of our latest work. If you are really involved and like to know specific examples, I recommend to you to look at the wiki. And in this case, there's a lot of action cluster. By action cluster, what we mean is case studies. And this is fantastic to learn about the community and is very interesting examples and cases. Now, what I like to do is share with you GCTC Agriculture and Rural Supercluster has selected 4 topics to focus on initially: smart agriculture, farm field mapping, improving rural outcomes and broadband access, and telehealth. We have started the work for more than 2 years, and of course, due to the COVID-19, some of the issues that we have been working on has come to more forefront. The leadership of the group is included, in addition to me, is from NTCA, Rural Broadband Association and Purdue University. What I like about this description is gives you the extent of what the agriculture and rural supercluster is talking about. Is really looking at how do we really help farmers, ranchers, people who are living in rural community leverage technologies to help them solve in terms of better farming, help in digital divide, homework gap, healthcare, and as most of you know, the news over the last few years, this has been one of the topics of that perspective. So agriculture and agriculture provided a blueprint, and this is one of the initial work that after 1 year, and in there you will see in examples like connectivity best practices, such that STEM, how do you go to the edge and leverage the edge in terms of getting better for the connectivity, some of the wireless technology that are used in the test beds. And in agriculture, we focus on sensors, look at business development, food sheds, food safety as an outcome, have a discussion regarding rural impacts and outcome. And in health area, we focus on rural hospitals, blockchain, and addiction. And there's a paper that you can download, the latest in our website. So, what is digital agriculture? And in this case, what would be good is digital agriculture, where you're leveraging some of the technology and improving the decision making for the farmers. The focus and energy for us should be how do we help the actual farmer or community to make better decisions and have access to information. Now, when you look at the perspective of farming, many of us miss the point of how complicated it is. As you know, of course, when you discuss about technology, we know rural broadband, a critical need. And also, there has been many, many new agricultural technology into the play for the last few years. But on the other hand, when you look at farming, you have to realize there's a lot of things involved in terms of regulation, how water is used, what is the energy, environment, safety, health. And I think that one of the critical element is when you put together a perspective, you need to look at all of these aspects to make an impact on the ground. And then, of course, this was done by Purdue University, and what the sixth level of precision agriculture adaptation. And I think the challenge that we all face is many, many examples exist, but not really good interoperability. You most probably need to have a PhD and a scientist in order to really get advantage of some of this technology. They are not ready for mass market usage. So what I like to do is, in order to help to share with you some of the things we have learned, is bring you two case studies. First case study is some of the work that was done in by California. The California Agriculture Innovation University of California has been in the forefront, the program called the WINE, and is focusing on really how agriculture and technology can help state of California in improving the activity. There are 8 topics, and it's very interesting engagement on that. And because of time, I'm just going to quickly go through some examples to share with you what is the state. So when California has been dealing with that, University of California, the biggest challenge with ag technology and innovation has been there's a lot of point solution, but not great integration. And I think that in that case, there's Silicon Valley and technology companies have really come and bringing a lot of stuff available, but they don't connect very well to the farms and the people who are leveraging that one. And I think that's one of the gaps that has been, and the program like Vine has been trying to bridge that gap. This is an example of ag innovation ecosystem. And what is very interesting is it deals with agriculture and food environmental sciences, how the computer science and engineering needs to be added, how open innovation, public-private partnership has to come together, and of course, the ecosystem to commercialize and incubate. Connecting all these four areas with the Vine partnership is the one they're working to solve. So what the activity that has been focusing on is how do I connect research, having working and meeting with the players, have an engineering lab in a real field testing, and of course dealing with indoor agriculture, wet labs, and rural and urban settings. To create agriculture technology testing at field innovation centers, they have been working on precision agriculture, distance learning, drones, conferences, field days, IoT testbeds, and agrobotics. Another activity by the Wine program is partnership precision plant breeding. In this case, as you can see, they're connecting sensors that connect plant, root, soil to genomics, cloud computing, data analytics, robotics, and of course, putting all of the end-to-end engagement of this integration. Next, what I'd like to share with you is Indiana case study. This is where Purdue University has really been working on some interesting innovation in this area where they are dealing with nanotechnology to a multiple electrical engineering and computer engineering program to very strong agriculture department and connecting all of the dots. They have developed a program called OATS, Purdue Open Ag Technology and System Center Development. And one of the key things they've been building is building some interesting study. This is an example of a real-time connection that is built in a farm field. And they're trying to make sure they do a mapping on this area. It's an example of a commercial called Farm Mobile, dealing with machine data, real-time harvest insight, timeline, playback, agronomic data, cropping system management, sub-acre management with data integration, machine connectivity for logistics and operation management, fleet management tracking, and AI farm plan modeling and input selection. Another commercial example, IOTA solutions, is integration of data from disparate system to deliver insight, and in this case is livestock, dealing with robotic precision soil sampling, crop intelligence from frequent high resolution imagery, dairy prediction, heat detection, analytics, and insight, and of course, a smart and variable rate irrigation control, multiple moisture tracking. One of these interesting things that they have developed is how to build a 500-meter base station in the sky, an aerostat, tethered aerostat, and a very interesting video that you're welcome to go look at, and nothing like height in wireless communication. Good 30 to 15 kilometer plus. In addition to that, Purdue is developing some very interesting manufacturing, all about sensors that are going to cause sense. And so this is a detail level on low-cost sensor manufacturing that was done in Purdue University. And their philosophy is if I can reduce the cost of sensors to sense, I can go and leverage this technology in a mass scale. What I'd like to share now is a couple of topics. As we had discussed in the area, the accuracy of mapping is a critical element. Is like understanding and what is the coverage area and what needs to be done. And one of the things that we have learned is the mapping is very missing, especially in the rural community. We actually, in our report, we have done some interesting thing in our blueprint collected in this area. Finally, when you look at wireless requirements that are being raised in here, as you can see, like any other application, you need things that are very low latency, like crop nitride sensing, to something that requires very, very high amount of throughput and data, like video and different application that is mixing. So one of the challenges for a 6G network to meet the need of the future rural and connectivity is how do I build a network that can serve all these needs? At the same time, this is not a mobile phone example that I can charge hundreds of dollars. I need to get very affordable cost to these networks. I want to thank you for listening to me. Appreciate your attention to this important factor. Agriculture and rural prosperity is a critical element for our future. My contact information is below, and if you have any question, I'll be glad to answer.